Good morning, good afternoon, good evening, wherever you may be and however you may be listening, whether this is your first time tuning in or you listen and watch every day, we want to thank you for spending your time here with us. This is the Water Online Show, powered by Water Online, the leading online destination for the water wastewater market. I'm your host, Travis Kennedy, and joining me as always is my co-host and chief editor of Water Online, Mr. Kevin Westerling.
What's up, Travis?
Hey, we have a big show here today. A lot going on. It's the beginning of the year here in 2025. I don't necessarily want to date this episode, but at the same time, where we are and what year it is important to the topic that we're going to be talking about. So, you know, I was thinking earlier that there's really no doubt that there are categorical leaders when it comes to topics of interest in the water wastewater market. I mean, there's topics like LCRI and BABA, and of course, everyone's favorite, the heavyweight champion of the world in terms of topics recently.
You know it's coming.
Yep, we're going to be talking about it because we have to and we should, is PFAS. And there's a reason for that. There's a reason why these topics, including PFAS, are consistently the top of mind and at the forefront of discussions in any water or wastewater conference or field office or township debate. It's because of the wide-reaching impact that these topics represent. I mean, PFAS can impact in what? We'll get more information on this, but 90+% of America. It's everywhere, and it's everywhere because we weren't looking for it until just a few years ago. But there are a lot of sources that lead to PFAS impacting mine and yours and everyone out there listening's an ecosystem and environment. So there's multiple ways it can be introduced into your drinking water and the drinking water that your customers consume. And one of those ways that we haven't really talked about too much is through biosolids, right, Kevin? We haven't talked about that very much.
Not so much. We've been focused on drinking water, but yep.
And it's timely in that because on the 14th of January of this year, the EPA released for public comment a risk assessment report that's evaluating the potential risks associated with land application of biosolids containing two types of PFAS, PFOA, and PFOS. And we're very blessed to welcome as our guest to help shed some more light on this topic, none other than Rashi Gupta, the National Wastewater Practice Director for Carollo Engineers. Rashi, thank you very much for joining us here today.
Welcome, Rashi.
Thanks for having me.
Well, thanks again, Rashi. And Travis mentioned the report that was just released, that draft risk assessment for PFAS and biosolids. So first of all, can you just tell us what conclusions that report came to, and did anything in it surprise you?
Yeah, so the risk assessment, one thing to note is it's not a regulation. So this is a kind of a precursor step to potential regulations down the line, but this is currently just a risk assessment. It was done around the so-called farm family. So it does not represent risks to the general population. It is instead, it is looking at a family that lives on a farm that has, they apply biosolids to their farm. They eat the animal products from their farm. They eat the crops. They might be drinking water that's on a drinking water well or their surface water supply. And so it's a very kind of hypothetical family with a very concentrated risk. That is what the EPA has done in the past as well in terms of assessing risks associated with biosolids. So that was not a surprise that they were doing that. They've been pretty clear about the fact that they were going to do that since they issued the roadmap. In terms of the results, so how they approached it, it wasn't that they determined, what a safe risk level is and then back into a specific concentration. Rather, they set a hypothetical, somewhat arbitrary concentration of 1 part per billion PFOS and PFOA in the biosolids, and then they ran their risk assessment models based on that. They looked at 18 different exposure pathways for those members of that farm family that could be exposed to the biosolids through one of those 18 exposure pathways. And an exposure pathway is just, and they were focused on ingestion. So not dermal contact or anything, but so more what are you eating? What are you drinking?
What are you drinking? Okay,
yeah.
Got it.
Also, one of the things is the family has small children, and the small children may be crawling around on the farm, may incidentally ingest some soil that might have some biosolids. So all of those things are incorporated into those exposure pathways.
Like a worst
So
case
based on,
scenario, I guess, right?
yeah, I mean, it's a potentially a realistic scenario for a small
Mhm.
number of people, maybe, but that is how they approach the risk assessment, right? And those risks are real for anybody that falls into those categories.
What about,
So,
oh, go ahead. I'm sorry.
yeah, so they found out basically that at that 1 part per billion concentration of PFOS and PFOA, that the risk tolerance or the risk associated with even that concentration did exceed acceptable levels for some of those scenarios. So that was kind of the main takeaway in terms of land application of biosolids, is that under the assumptions and the scenarios they modeled, the models that they used, and all the assumptions built into that at that concentration, which is relatively low, it's lower than most biosolids. It's on the low end of the spectrum of what most non-industrially biosolids in the country. The risks were higher than what the EPA shoots for, which was about a 1 in a million chance for cancer. They also looked at non-cancer risks. So that was on the land application front. They also looked at what they call surface disposal monofills, which is actually a pretty small proportion of how biosolids are managed in the country. Most of the biosolids are either land applied, that's about 50%. And then the big other two pathways or disposal methods are landfilling or incineration. And then everything else, which is surface monofill, incineration, deep well injection, those types of things are very small pieces of the pie in terms of biosolids management. But they did not look at landfilling in terms of municipal landfills. They looked at only the surface disposal monofill, and they did find that at certain levels of PFOS and PFOA, there was risk associated with the surface water if it's exposed. If it leaches into the surface water, then there's a higher risk than was considered acceptable from that situation. And then on incineration, they provided some qualitative commentary about risks associated with incineration, but they could not quantify the risks because there just isn't enough data on incineration. So that's still research and work outstanding.
I mean, it's interesting as you were going through some of the conclusions of the risk assessment, that it seems as if they're talking about and elongating the data to center around a very specific subset of the population. So let's take into account the non-farm families. So, the suburbs, the urban areas. Like, does this affect them at all?
I mean, there's risk associated with pretty much any exposure pathway for PFAS. And unfortunately, PFAS is in just about everything.
Everywhere.
Right? It's in our food packaging, it's in our nonstick pans, it's in our clothing. We've all heard that before. And so we have exposure pathways associated with all of those things. So the specific risks associated with biosolids and, the PFAS and biosolids getting into some sort of a food product and then making its way into a family's diet, that it's up for debate as to how much risk there is associated with that for the general population. However, it's not a non-zero risk, right?
Right. There's definitely a risk there, right? I mean, when you go and think about it, I mean, it's interesting. You can draw the line from most of our food, if not all of it, comes from a farm of some kind, right? Whether that's vegetables, fruits, or meat, right? So to draw that line from farm to where you get your food source, where it comes from originally, I mean, there's a direct correlation there. So there
is, but I wanted to point out, Travis, that biosolids are not applied on every single piece of farmland we have in the country. It's actually they're only land applied for a pretty small proportion of our farmland.
Okay.
And so it's also not the case that every food crop or every milk product, every fish coming out of a stream is necessarily exposed to PFAS from biosolids. It's a small proportion of that farmland that we're land for biosolids.
Yeah, cancel alarm. Everybody. Okay. All right.
So Rashi, what are the next steps from a regulatory standpoint if they are to proceed with regulations out of this risk assessment? What are the next steps?
Yeah, what EPA has said in the past and what I understand that they will do, and it was a little bit, out of norm for them to issue the risk assessment without a risk management element and an associated regulation. So this was a little bit abnormal, but we understand that they've issued the draft risk assessment. So it's open for comments for the next 60 days. The comment period ends March 17th. And so once they get comments, they will look at those comments, address those that they feel are appropriate to address. They may change their assumptions and methodology based on the comments that they receive. We don't know. And then either at that same time or thereafter, they will incorporate what is called risk management. And that's the piece where you look at the true, like, how do you actually manage the risk? What is the actual feasibility of any sort of treatment? And what are the costs associated with it? And then once you've incorporated both that kind of the assessment piece and then the management piece, because there may be pretty cost-effective ways to manage the risk that don't necessarily require destruction, which is very costly. They will take all of that into account and then issue potential regulations that will be, again, draft, open for public comment, and then ultimately promulgated potentially, depending on how all of that rolls out.
Oh, there's a lot of big words in there. I think I got most of it, which is going to lead me to my next question. Going off of what you just described as like the sort of like the next steps, but from a utility standpoint, like I know how much utility we collectively, we know how much utilities love regulations, because typically when they are released, they're very clear and they give a long time to adapt. So it never causes any confusion. But what are the immediate steps that utilities can take to prepare for possible, I'm not saying it's going to happen, but possible biosolids regulation?
Yeah. So actually the EPA suggested a few things themselves in this draft risk assessment that would be kind of looking at the sources, like, understanding your data. How much PFAS is in your biosolids now? Are there potentially some industrial sources that are kind of easy things to control at the source? Do that. So you're reducing the amount of PFAS that are coming in to the extent possible. But industrial sources are not the only source. We talked about how universal PFAS are. And like in California, which is where I'm based, most of our PFAS is actually not industrial. It's just straight up residential municipal products that are, flushed down the toilet or in the sinks and in our dishwashers and things like that. So there is also then, that baseline PFAS that we have to deal with. And so utilities have multiple things that they can do in addition to looking at the data and for their own biosolids right now and trying to control that industrial sources as well as they can. They can also talk to their land application third parties, if they have a third party, or if they're doing it themselves, kind of manage the risk associated with where they're applying their biosolids right now. So getting them away from potential runoff into surface water, is that where fish might be, fish that are consumed, putting it on crops that are not for grazing or for animal feed. Those are some risk management things that utilities can do. And then in addition to that, I think strategic master planning we have for years advised our clients to diversify their biosolids management portfolios so that their apples are not all in one basket, or their eggs are not in one basket. So understanding what the options are and setting themselves up for if this, then that, I think is really important. And as part of that, understanding what are the triggers that are going to require them to shift to something else? What is the time frame for making that shift? And how much is it going to cost? And then taking that information and coming back and making sure that their stakeholders, which are their ratepayers, the legislators, the regulators, all understand the consequences of this action in terms of time frame and cost. Because I think the cost element especially has been missing largely from the conversation thus far. And this is going to take quite a bit of money. And ultimately, our ratepayers will be affected. We can talk about who's responsible and everything till we're blue in the face, but ultimately, I think the ratepayers will be affected.
Yeah, it always comes down to cost too, right? Like cost and safety. I mean, those two things, you got to find a way to balance it.
Yeah, and so what about these agricultural partners who are getting their fertilizer from these municipalities, in some case purchasing them? Um, what should the utilities say to them in this discussion? Should they just cease and desist right now and go, the traditional route, or what does that conversation look like?
Yeah, so there's actually a lot of guidance that the industry has produced. NACWA and WEF have all produced different types of materials in terms of having those conversations with our agricultural partners. I think it's very important to understand and recognize that there are certain farmers, especially like those in Maine with the dairy cattle, that were truly impacted. And those issues have to be addressed and made right. But I think the reason why our agricultural partners have been applying biosolids for so long is because of the benefits, right? It's a low-cost fertilizer. It has a lot of nutrients, has a lot of carbon, and those things are still true. So, not every single ton of biosolids has the same level of PFAS there. And we've talked about, what are the true risks? What are the types of crops that are grown? So in terms of this conversation, I think being transparent and informing our farming partners about the true risks associated with the land application and ways that they can mitigate those risks are all parts of those conversations that we need to be having with them. And I do think that the management element of the risks is probably the best first step because the cost to the farmers of having to procure fertilizer that is considerably more expensive is not negligible either. So there, like we said, the balance of that cost and balance, that equation is important, not only for for the utilities, but also for our farming partners.
I mean, our farming partners are up against it to begin with, right? I mean, trying to make sure that the business that they run it makes enough profit so that they can be sustainable. So they're up against it already. So that's a good point. I want to stick to the question around the treatment process. So you had sort of mentioned it in terms of how we balance the treatment of this along with all the other factors, but how will the process itself need to adapt to meet this potential, not saying for sure, but potential new requirements?
Yeah, so we all know that the wastewater treatment plants, the utilities, they're not producers of the PFAS. PFAS are coming in with their influent sewage. And then as they're within the treatment plant, the PFAS are transforming from PFAS A to PFAS B and splitting into the liquid phase and the solids phase. Unfortunately, they don't disappear, right?
Yeah.
Like
unfortunately,
I always say,
it'd be good if it did.
Conservation of mass still applies.
Yeah, problem solved
today. So we have to look at it both ways. We have to look at kind of the liquid side and the effluent. We also have to look at the biosolids. Today, we're talking about the biosolids. So while we don't know what might happen down the line, let's say, for example, that the regulations are promulgated and do necessitate some sort of destruction of PFAS. To date, the knowledge that we have right now is that there are some advanced, high temperature processes that may destroy PFAS to some extent. Some of them based on kind of the PFAS that we are actually able to measure right now. So we only have like 40 target analytes, right, that are part of the 1633 method that typically are measured for. Of those, the solid product from a process like pyrolysis has indicated kind of a non-detector, a very high level of destruction in the solid phase. However, the PFAS, again, it doesn't destroy. That carbon-fluorine bond is very strong. And so it's volatilizing potentially and coming out through the exhaust phase, or it's coming out in the condensate stream from that exhaust. And so we have to research and understand each of those places, because if we're truly talking about destruction, we have to truly destroy it in all phases. So let's say, for example, we have a way to do that. We put a regenerative thermal oxidizer on the exhaust phase. We have the pyrolysis system. For a utility that's considering that right now, they also need to understand what's required upstream of that pyrolysis system. So you got to be able to dewater your solids. And then you have to dry the solids ahead of that pyrolysis system. And that's true for gasification as well. And then you have to be able to store the material in between. You got to have the exhaust scrubbing and cleaning, the emissions controls, all of those things have to be part of it. So these are complex mechanical systems. They're going to cost quite a bit. They're going to take a lot of time to design and construct. All of those things have to be thought about for utilities that are considering this. There are other technologies as well. So we talked about pyrolysis and gasification. There's kind of additional, even more emerging technologies. So a lot of people have heard about supercritical water oxidation, which should be, it's not current, it's being demonstrated at kind of a demonstration scale in Orlando. It's going to be demonstrated down the street from me here in Orange County at some point this year, hopefully. But we just don't have enough data right now in terms of its reliable performance and how well it will work at a normal, like real life, everyday treatment plant. And then similarly, there's a process called ultra high temperature ionic plasma gasification, which ups the ante even further. And like I like to call it, basically creating lightning in a bottle or trying to recreate the sun on Earth. So here we're talking temperatures.
Yeah, right.
Yeah.
Sounds like a
We're talking temperatures like
invention.
3 to 10,000 degrees Celsius in that process. And so that
sounds simple.
Again, there's no full-scale permanent installation for that, but there's a demonstration facility out in Tennessee, which can run some biosolids through it for people to be able to see. So these are very non-traditional technologies. They're high temperature, potentially high pressure. There's safety issues. There's concerns about capital costs, operating costs, reliability, robustness. How, I'm an engineer, so how well are the materials of construction going to last under all of those conditions?
Important questions. Important questions, right? I mean, you ask the important questions, and that's what we're getting to on the Water Online show. Need to ask the important questions, the tough ones. That's why we're here.
Well, and the practical ones, right? Because that being the case, and it being expensive, still experimental. If we're not quite there for destruction just yet, and you have utilities looking at this land application question going forward, what alternative disposal methods should they be considering at this point, just in case this comes down?
Yeah, and that's a hard question because utilities, they can't just, snap their fingers and have a management option available to them, largely speaking. Again, we talked about kind of the three main disposal or end use options currently available: land application, landfilling in municipal landfills, and incineration. Well, each of those three are in danger. We talked about land app all throughout this entire show. Landfilling is also in danger. One, because the PFAS ends up in the leachate. The leachate goes back to the wastewater treatment plant. So you have this ugly circle of PFAS running around. The landfills are concerned about their own liability. So some of them have stopped taking biosolids because of the PFAS concern. They've also stopped taking it for non-PFAS reasons, where they have issues with structural stability of landfill cells, that their landfill cells have actually failed in some places. And so in the Southeast, some landfills have stopped taking biosolids because of the structural concerns associated with the biosolids, which are pretty wet. And then the other thing is that in some places, like in California, we have regulated or legislated organic diversion goals, where we're trying to remove organics from our landfills to reduce greenhouse gas emissions. And so disposing of biosolids in landfills is not really a viable option in certain parts of the country. So landfilling is not necessarily a long-term sustainable option. And incineration, we talked about, it's almost impossible to permit in some parts of the country. It's unknown what it's going to do for the PFAS. It's still under research. And it's a high temperature, process, often has a lot of public opposition, is difficult to permit. So all of those reasons have made where the incinerators are even right now in the country pretty limited in terms of where they are in the country. So none of those are necessarily long-term sustainable options. So I think it's really important for utilities to try to diversify. And so they do have a landfill option now, secure it, make sure that it's available for as long as they can. If they have an incinerator on site, keep it running
Yep.
and use it for as long as you can. And then again, work with your land application contractors and try to mitigate the risks associated with the land application to the extent possible.
It's no doubt that Carollo is at the forefront of a lot of these emerging threats to our water systems, and I'm fascinated with just how knowledgeable you and other engineers at Carollo are about this topics that you specialize in. I think it's absolutely amazing. If any of our users out there wanted to get more information or perhaps work with Carollo on any of their projects or the issues or problems they're faced with, what's the best way to get started in connecting with Carollo?
Yeah, they can contact me. I'm on LinkedIn. I can provide my email address. They're welcome to talk to me. If they have specific PFAS questions, we also have an amazingly brilliant gentleman, I believe, who's been on your show before as well, Kyle Thompson.
Oh, yeah.
International PFAS lead.
Mm-hmm.
And so Kyle is available as well. So contacting either one of us or really anyone at Carollo, and they'll get the person that's interested in contact with us. And we're happy to talk to anybody.
Carollo Engineers leading the way as usual. I would expect nothing less from industry leaders like Carollo. Rashi, thank you very much for joining us here today. A lot of good information. We appreciate it. And for all of you out there, thank you for spending your time here with us today. And we can't wait to see you next time.
Thank you so much, Travis and Kevin. Take care.